Hi, in this video I'm going to introduce you how to using the inverse matrix, by using the inverse matrix to solve this linear equation, right? Linear equation in 3 variables. So if they're saying using inverse matrix, means they are using adjoint matrix. All right. So now I have I have tell you using the adjoint matrix. So how to using adjoint matrix? Okay, you have to rewrite this matrix in the form of matrix form. All right, matrix form. So means that the x, y, z, all the x, y, z I will write as x, y, z here, and this will become your 3, -3, 13, and this will be all the coefficient for the x, y, z here. So 1, 1, 2, -2, 3, 4, 5, -4, and -1, right? So this one become the matrix multiply x, y, z, you were getting this. This is in the matrix form, right? This is the matrix form. So matrix form. So means that it's in this form. The matrix A multiplied with x equals to b here. Means that now this is your matrix A. This is your matrix A, and this is your matrix X. This is your matrix B. So where A is a 3 by 3 matrix, right? 3 by 3 matrix. So, okay, I will explain why I'm writing all this. So you see that if I want to find X, X here refer to the X, Y, Z here because I want to find the X, Y, and Z. So I must make sure that A there are no A here. So means there are only X here so that I can find the X, right? So how I multiply A inverse both sides. Okay, I multiply A inverse both sides, but on the left hand side because I want to get rid of the A here, so I multiply A inverse and A inverse. As you know that A inverse and A, it will turn to identity, right? So A inverse and B. So finally I and X, you were getting X equals to A inverse of B. This is the formula. Alright, so means that if you want to find the value of X, Y, Z, you have to find the inverse of this matrix. You have to find the inverse of this matrix based on this formula. Multiply the B here, means multiply with this B. Then you will get the value of X, Y, Z. So since the question asking you to by using the inverse matrix here, means using adjoint matrix, this is an important point here. So that's why I will show you that I already find the adjoint matrix. So as you remember in the previous video, if you forget the process of finding determinant, you refer to the previous video. If you forget to find the adjoint matrix, you refer to the video that I talk about adjoint matrix, right? So this is all the I write it out because I want to show you that this is the step that you must write. Okay, now so now the step 1 is you finding determinant because you need the A. You want to find inverse of A, you find the determinant of A, right? Which I already done for you. So the step 2 here will be you finding the adjoint matrix. The adjoint matrix is defined as the cofactor transpose, right? The cofactor matrix transpose. And the third is you find the A inverse. The formula for A inverse is 1 over determinant of A adjoint of A, right? And finally, your third step, your fourth step is you find the X, Y, Z by using inverse of A multiplied with B. So, okay. Now I have done for the first 2 steps, where the first step you are very familiar with, you find determinant. So I'm finding the determinant by using the first row, expanding the cofactor. Can you see that? 1. I follow the sign of the cofactor matrix, positive 1, and the minor 3, 4, 4, -4, -1, and -1. The minor for 1 will be -2, 4, 5, -1. So and so far, and I'm getting the value of 17. So for adjoint matrix, you know that you need to find the cofactor matrix, right? The cofactor matrix here refer to the cofactor of each of the entry here. Alright, each of the entry here. So for example, how I getting this? How I getting this? Because for this location here is negative, right? I write negative. How to getting this? So for this entry here, so I have cancel out the row and the column. I have 1, 2, -4, -1, 1, 2, -4, -1, right? So to get this entry here, I refer to the sign here is positive, right? Positive. So I put the minor. So for this entry means refer to this. So what is the minor? You see 1, 1, negative 2, 3, right? Negative 2, 3. So after I getting all this, so then I evaluate. Okay, negative 3 minus 16, right? Negative 3, okay, 3, 4, 3, 4, sorry, this is negative 4, negative 1, right? So if you have negative 3 plus with 16, you have 13, right? 13. Then you're getting all the value, then you transpose. Transpose means you take the row here become the column. Can you see that? 13, 18, negative 7. And this one also the same. Negative 7, negative 11, 9. Negative 2, negative 8, 5. Alright? This is, I think you already understand what is the meaning of adjoint matrix. Then done for the step 2. Now we're going to finding the inverse. Right? The inverse. So, to finding the inverse is 1 over determinant. Right? 1 over the determinant multiply with the adjoint matrix. The adjoint matrix will be 13, negative 7, negative 2, 18, negative 11, negative 8, negative 7, 9, 5. The special in this question is you want to solve this equation, right, by using the adjoint matrix. So now we go for step 3. We're using the adjoint matrix. So, okay, I'm not going to multiply the 1 over 70 inside for this case because I solving equation. I want to avoid many fraction here. So what I do, I straight away jump to step 4. Alright, the step 4 here, I want to find the x. The x here refer to the xyz, which is equals to the determinant. Equals to the inverse of A. You put it inside here. 1 over 17, 13, minus 7, minus 2, 18, negative 11, negative 8, negative 7, 9, and 5. Right? Multiply with the B. The B here. The B here refer to this. 3, negative 3, 13. 3, negative 3, 13. I don't multiply the 1 over 17 inside here, but it's okay if you want to multiply, but it's very tedious. We don't do this. So we have to multiply these two matrices first. This is a 3 by 3 matrix, and this is the 3 by 1 matrix. The number of columns here is the same as the number of rows here. So yes, it can be multiplied. You will produce a 3 by 1 matrix. 1 over 17. You will produce a 3 by 1 matrix. Means they are, okay, 1 column, 3 row. So how to getting the first row? You have to take the first row multiply with this column. 13 multiply 3, negative, negative, positive 21 plus with 6. Right? 3 times with 13. Negative 3. Okay, so then you follow by 18 times 3, you have 54, right? 18 times 3, you have 54. Followed by positive 33. Positive 33 minus with 104. 8 times 13, 104, right? Plus 33, 54. And you have negative 21. Negative 21, go for the third row with this negative 21 minus with 27 plus with 5 times 13, 65 I think. Okay, 65. Okay, this is the purpose why I don't multiply the fraction inside. So then you have 1 over 17, 13, right? Sorry. 3 times 13 plus 21 plus with 6. Sorry. Oh, sorry, this is negative 26. I've calculated wrongly. 13 times 3, you have 39 plus 21 minus with 26. Sorry. So you have 3 times with 13 plus 21 minus 26, you have 34. Okay, 34 for the first row, and 54 plus with 33 minus 104, you have negative 17, and lastly, negative 21, negative 27 plus 65, you have 17. Alright, and now only you multiply the 1s over 17 inside. 34 divided by 17, you have 2. Negative 17 and 17 have negative 1, and 17 and 1 over 17 have 1. So this is your x, y, z, right? X, y, z. Now you have solved, right? You have a unique solution already. Unique solution means there is only one x, y, z, one set of solution that satisfy this linear equation, which the x will be 2, and the y is negative 1, and the z is 1, right? So if you can actually using this calculator to check your final answer, right? So final answer, you can just key in the you can choosing the menu, then you go for the equation, going down, then you have alright, can you see that there is an equation here, this one, right? This one, the A. So you're choosing the A here. So where's the A? So you're choosing the A here. Then you have simultaneous equation. You're choosing one simultaneous equation. So how many unknown? You have 3 unknown, right? 3 unknown. So you're choosing 3 unknown. Alright. So then you key in everything. You will get something like this. You key in the coefficient, means you go from the left to the right. 1, 1, 2, 3. So you key in 1 equal, 1, 2 equal, 3 equal. Right? You can see later it will go for the second row. Second row you have negative 2 equal, 3 equal, 4 equal, and negative 3 equal. Right? Followed by 5 equal, negative 4 equal, negative 1 equal, 13 equal. Alright. Then you're pressing equal. Then you have x equals to 2. Then you have x equals to 2, right? You're getting x equals to 2. Followed by negative 1. Y is negative 1. Alright. Exactly the same. So, and go for another one. Z is 1, right? Yes, exactly. Z is 1. So, means for this video, I just showing you how to why we are using this method to solving this linear equation here, 3 variable, right? By using inverse matrix. When they see the words inverse matrix, means refer to using the adjoint matrix to find the value of x, y, z. So you have to follow the step that you find the determinant of A. You have to rewrite this in the form of matrix form. And step 1, you have to find the determinant. As you know, you have already know how to find determinant. So then you find the adjoint by doing all this. Be careful while you're doing this. So you're getting the adjoint, and getting the cofactor, you transpose the cofactor. Then after that, you find the A inverse, and finally you get the value of x, y, z by using this formula. Alright, I think that's all for this video.